the what from her, and then this is the how. We're building a satellite for UCSC. And it primarily was for Amateur Radio Club. Peterson, who runs the Amateur Radio Club, it was kind of his idea, but it became a senior design project, which is going to be multi-year. We made significant progress this year, though, and I'm on the team building the communication system. Like, we're making our own so that we can do like different than a lot of people do. So we're doing specialized bands, so all the people who are really geeky hams, we'll use ours. And it's really cool too because it hits the ionosphere weird and will go somewhere way across the earth than you thought it would. That's not in like the footprint. If that makes sense. So it's really cool. So people are really interested in that. So that goes with the communicating with people, being exposed to other cultures, and nerding out with other people with the same interests. And also disaster relief. That was one of our main things as well. And in addition to the amateur radio, we also have a secondary payload because we're partnering with the Santa Cruz Institute for physics. And this is actually outdated. We were going to do ionospheric precipitation, but now we're doing terrestrial gamma ray flashes. So it's gamma rays that go in, because we're right above the ionosphere, from like lightning. And we're trying to prove the existence of low power, because all the stations on Earth can read the high power ones. So that's cool. And so yeah, and it really benefits the university too, because we're not really known for our engineering department. But once you have one of these, you become a CubeSat university. And it just raises the bar and brings in a lot of investors. And Cal Poly started it, and we recently went to a CubeSat conference there, because they invented them. We talked to the students working on those, got a lot of tips and tricks, met people at NASA and stuff. We're trying to get like a launch plan right now. But yeah, it's really awesome. I've learned so much, and I like all the positive outcomes of building this, and we're determined to make it happen. And she'll be doing it next year, handing the torch. So, yeah. Questions? Probably.
Yes. Probably first. Okay. I feel like I have many questions.
Okay. All right.
Let me ask the practical question first. In order to launch a satellite, do you need to get permission?
Yes. Depending on who you want to be your launch provider, from the beginning of building, you follow their specific rules. So we did research into what NASA wants for them to launch for you, and that's what we've been following. Like, you can only use 2 different kinds of aluminum for the exterior. You're not allowed to have charge pumps in your phase lock loop of your communication. Like, there's specific rules that you're not allowed to do to go. You can't have certain you can't have thrusters and stuff. So we designed around what NASA would do. And within the last few days, actually, we found someone who was on the ham team, in the ham club, who found us a possible launch, but what's not with NASA, but hopefully the same rules apply. But we might have to adjust things around that. Does that answer your question?
Yeah, it does.
Okay.
But do you have, actually, one more question, same line. Do you need to go to the government and say, I'd like to launch something in...
Yes, that's later down the road. For now, we're dealing with the FCC rules and NASA's rules, and you get permission around, with NASA kind of handles that with you.
Mm-hmm.
It's like, they won't launch it unless you're allowed to, so.
Well, that's good.
Yeah.
And when are you hoping to launch?
What?
What's the goal, is there a date?
It's 6 years.
6 years.
You usually wait around for a while. We want to be done, we'll probably be done within the next 2-3 years, based on how much we have done so far. But yeah, it's about 6 years from when you talk to them and they say they're ready till you actually get it to happen.
This is so interesting. The student timeline and the satellite timeline are really, they're not aligned.
Yes, yeah, and we're trying to figure out a way to solve that it's just a senior design project, because then it kind of messes with the continuity of it. So so far, just what we've had is working with the Amateur Radio Club. So we have people like her and the president who hang out with us in the room and are already being integrated onto the team before they're actually on the team. And I'll also be here next year being a tutor for the team, which helping them start where we left off. Because this year, it did start last year, but it was basically a disaster. We had to restart from the very beginning because they didn't leave any circuits, any schematics, any documentation whatsoever. So we had no idea what they did, and we started all over. But we're dedicated to that not happening again. And with good documentation and bringing people on early and some people staying late, we're hoping that it helps a lot.
So this is also about collaborative work and documentation, and dare I say, writing in the field of engineering.
Yeah, our reports are about 200 pages long.
Yeah.
I'm the editor of the report. I'm, as my teacher says, one of the only engineers who actually knows how to write. So,
Be surprised.
yeah. Well, on our team there's 2. So, yeah, I've been doing that, and it's good. But a lot of people are really bad at writing. We're considering, well, my teacher, since the undergrad advisor, wants there to be a class about writing specifically for engineers, because so many engineers, their lab reports are just terrible and you don't know what they did.
There is CMP 185. It's true.
But it doesn't really teach you. And that's the problem. You learn how to make a really cool poster, and you get to reuse a lab report. Like, you learn a little bit, but we mean like, how would you make your sentence explain what you actually did, and not just throw in big words and not explain them and string together a sentence that doesn't make any sense. And that's what a lot of people do. And especially me correcting the document, that's what a lot of engineers write. They're just like, oh, these people know this word. And someone who's an EE 101 student should be able to read your work and understand what you did. So that's our goal, is not expect people to have the same background as us when they read it.
So I just have to applaud that ambition as a teacher of writing. That's basically the main thing, almost the only thing. In fact, here we are, several teachers of writing in the room, and yay.
Yes.
Carry on.
Yeah.
We support it.
Yeah, and they also made 185 not a requirement anymore for EE. And we need one specifically technical writing for engineers, like writing. So, I don't know, that'd be good. Building satellite. Okay.
So you mentioned that you moved away from detecting ionosphere precipitation. Can you reiterate what you're actually focused on now?
Oh yeah, the terrestrial gamma ray flashes. We switched to that. I'm not on the science payload team, but I know what she does a little bit. So we switched over mainly to power consumption, because it's a really small satellite. This one's a 1U, but ours is 2, so it's 10 centimeters by 10 centimeters by 20 centimeters. They're miniature satellites. That's why universities make them. So there's on the roof of solar panels. So we switched over for power, and there's less constraints of our position, so that helps out with like our attitude control. So it was just like a lot more work, more complicated, more expensive to do this one. Or you also mean what it is.
Are you looking at gamma rays that are coming from the sun, or are you looking at gamma rays
From lightning.
Gotcha.
Yeah, and then they hit the ionosphere, and then they go into space, and we have sensors for it, because we're having 2 scintillators, one that detects like the high energy gamma rays, and those we already know exist because we get them all the time on Earth. There's a lot of science stations for this. But this will be the first experiment ever that's trying to detect low ones. The high ones is just there so that we know it works, and low ones are just, we're trying to, theoretically they exist, but they've never been proven. So that's the goal.
Okay.
So hopefully that works too.
Well, thanks so much,
Yeah.
Sage.
Yeah.
I mean, your satellite is going to be a fraction of the size of the picture.
It is about that size.
That's 20 centimeters.
No, ours is gonna be bigger.
Yeah,
This is about 10, but it's about 10 by 10. It's this big.
So cute.
Yeah, it's gonna be layers of circuit boards basically inside.
If it doesn't work, it's
Well,
a
thank
bad
you.
one.